the following Monday, I think it's the 13th, I will not be there. So I will be sending out a recording for you to watch whenever you feel like it. And we won't have class like in person. So you'll have a free period. Since everyone is in high school, they're willing to let me do that at Learning Tree. Oh, number 3 and 3.4. I sure can. Give me just a second here. Okay, 3 and 3.4 is, match the description of the slope of the line with its graph. That one? Hello? Oh, that's right, Jake, you have practice. Bummer. All right, so I'm not sure who asked for 3 and 3.4, but number 3 and 3.4 is on page 175, and there's actually 3 graphs there. And it says, match the description of the slope of a line with its graph. So we have number 3 says m is positive. So when they say m is positive, they're talking about the slope, right? Because m means slope for whatever reason. Someday I'm going to look that up and figure it out. And we have 4 as m is negative, m is 0, m is undefined. So let's refer to our friend Slope Dude. When m is positive, puff, puff, positive, right? That's when he is puffing up the hill. So which of those 4 looks like he's going up the hill? Yes, Slope Dude, right? I would say that D, so if you have your book, D looks like he's going up the hill, right? And then number 4, we'll just do 4, 5, and 6. 4 is when the slope is negative. So when the slope is negative, it's nice negative, right? He's negative. He's going down the hill. Who doesn't want to ski down the hill? You don't want to have to ski up the hill. Slope is 0. So remember, this is 0 fun because he's just chugging along on this flat line. So number 5 would be B because it's just this horizontal line. That's when the slope is 0. And 6, what is the worst curse word in math according to Slope Dude? Undefined, right? That's when he falls off the cliff, he's undefined. So 6 would be C. All right. So that's that. Any other questions? All right. I can't remember my brain. I'm telling you guys. I know we were in here. I know we did example 1, and I'm pretty sure we did number 1 here. I don't think we did example number 2, if I remember right, is where we're at. So did we do this example 2? Write an equation of the line passing through the point that is parallel to the line. Oh, I think we did do that one. Yeah, we did that one. We didn't do this one. This number 2. All right, so let's kind of just warm up our brains. I'll pull these over to Paint so that we can work with them. We are talking about, so the last part of this, the first part of this whole chapter, right? Just to kind of review, the first part of this chapter was when we had two parallel lines and we talked about a transversal line that cut through it. So we spent a lot of time talking about transversal lines, and there was a lot of theorems and properties that had to go with that. So when you get ready for your test, make sure you review all of those. The second half of this chapter has to do with the slope of the line. So that's what we were just talking about, right? We know kind of what to expect of the slope when it's, positive or negative or 1 or undefined or 0, all those things. So now we're going to take it a little bit further, and this is probably the section where the most algebra comes back in. All right, and we can still use our geometry and our algebra together to solve these kinds of problems. So what we want to talk about is one of the kind of most famous formulas or most famous equations in algebra and math in general, and that is a linear equation. Someone said, when will we do our test? Well, we have 3.5 and 3.6. So we will definitely finish all those up by Monday. Then I am out. So then you'll have 2 weeks to get your test turned in after that. So it'll be, is that the 20th will be your chapter 3 test will be due? Something like that. All right. I will send everything out in an email too, so you don't have to remember all these dates off the top of your head. Okay. All right. So who knows what this famous equation that we use all the time is that defines a line? Anybody know what that is off the top of their head? It has to do with the slope. You use the slope and you use the y-intercept. There we go. Y equals mx plus b. All right, so definitely before you go to take your test, review the slope-intercept form because it will be very, very helpful to you. Okay, it's my hint for the day. All right, y equals mx plus b. Okay, this is our equation for a line where m represents the slope, okay, and b represents the y-intercept. All right, so let's actually, since we are online and we have all these cool resources, let me pull up a, let's see, Desmos. So some of you may have seen this before. Some of you may have graphing calculators. All right, if you do not, this is a tool that I like to use when we get to Algebra 2 and use it a little bit in Algebra 1. And it's called Desmos. It's a graphing tool. You can also, some of you might have TI calculators, so you should be able to do this as well. So what this is a graphing tool. So you can actually see, what does this y equals mx plus b mean? All right. And they actually let you put little sliders in here so we can move the numbers around. So let's start with the very, 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 very basic equation. Okay. Y equals 1 times x plus 0. So kind of the standard equation that's out there is y equals x. That's what's graphed on there right now. Okay, so when x equals 1, y equals 1. So you can see right here, right? When x equals 1, y equals 1. When x equals 5, y equals 5. When x equals 7.07, then y equals 7.07. That's pretty easy, right? That's pretty straightforward. And this particular line has a slope of 1, which makes sense because out in front of this x, we would assume that there's a 1, right? And our slope is our rise over run. So if I rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. It works out graphically. Okay, so now what happens if I kind of play with my slope a little bit? Okay, what if in front, I'll just leave this up here. What if in front of my slope I put a, I don't know, 4? Okay, so I'm not doing anything with the y-intercept. I'm just showing what happens with the slope, right? I put in a slope of 4. It's still, my slope is 4. It's still positive, so I'm puff, puff, positive, right? I rise 4. 1, 2, 3, 4. I run 1. I rise 4. 1, 2, 3, 4. Run 1. So can you see how that slope pops up on there? If you put in a slope of 0, you get your 0 fun line, right? If I put in a slope of -2, okay, I get my nice negative, right? So I can rise -2, run +1, because remember, a slope of -2 would be like -2 over 1. Or if I really wanted to make it clear, I could do like -2 over 5, let's say, right? So I rise -2, so I'll start here. I go down 1, -2, and over +5. Down -2, over +5. Or I could rise +2, run -5. Rise +2, run -5. So that's just graphically showing you how slope looks like, what it looks like on my graph, right? Then we have, up to this point, we haven't done anything with the b. B is just our y-intercept. So if I have this y equals -2/5 x, okay, we'll just keep that one, and I copy it, but I add 4, okay? This is my plus b, this is my y-intercept. Here, this is basically like +0, right? There's no y-intercept, so we intercept the y-axis at 0. When I look at my purple equation, right, I have +4. So my y-intercept is at when y equals 4. It's right here on my graph. Okay, if I say take the same equation and I put a y-intercept of -3, -3, right? This black equation has a y-intercept at -3. So you can see where that number comes from, right? Our purple equation has a y-intercept at +4, so you can see it intercepts at +4. Orange, 0, or black equation is at -3. Okay. I know that some of you guys may have seen this a lot, and you're like, okay, I know this, okay. This is just a super important concept. I don't know for Kirsten or Greta, I don't know if she's online or not, but when you guys took your PSAT, did you have some questions about slope on there? Yeah, it's definitely one of those concepts that is going to come up. So if you take any more math classes, you'll still be talking about slope. If you take your college tests, they'll be talking about slope. It's just one of those things that I really want to make sure everybody understands, because it's important to understand, what does slope look like and how can I use this equation to figure out the slope. So we might have trickled a little bit into algebra there, but I think it's helpful to see visually how that works. All right, so now back to our problem. Okay, you guys are like, just do the problem. All right, write an equation of a line that passes through the point -2, 5 and is parallel to the line with the equation y equals -2x plus 3. Okay, so I actually can show you this graphically. Since I have Desmos up, I might as well show you. What are they asking for? Okay, let me make this a little smaller so I can see 2 and 1. Okay, so what they're saying is that we have a line that is going to go through a point at -2, 5. Okay, so there's my point, -2, 5. All right, and the line is going to be parallel to y equals -2x plus 3. Okay, so let me pull this up a little bit bigger here. Oh, just kind of another side note, because if I'm going to talk about this and you're going to see it on your PSATs and all that stuff, right? This blue line here is a graph of y equals -2x plus 3. This blue line is all of the answers to this equation. Okay, so remember when you write this, this means x equals -2, y equals 5, right? One of the answers to my blue equation is when x equals 0, y equals 3. Another answer is when x equals 1.5, y equals 0. Every single little point along this line is an answer to the blue equation. So that's why it's kind of so important, because any point that you pick along here is a solution to the blue equation. So that's why we're so interested in lines. All right, so basically what we want to do is we want to find an equation of a line that is parallel to the blue line and it goes through this red point. So you can probably see where this line is going to go, right? But we need to figure out how to write the equation of the line that actually goes through that red point and is going to be parallel. All right, so the first thing that we need to do is we need to, for some reason they gave us this original equation. Okay, so they gave us the equation that it's parallel to. What do we know about this equation? What do we know about this equation? We know that the slope of this equation is -2, right? And we know that the y-intercept is at 3. All right, we want to find an equation of a line that is parallel to this. What do we know about parallel lines and their slopes? There was a postulate that we learned, and it's also something that kind of like you probably just should know. So what do you think about the slopes of parallel lines? Should they be equal to each other? Anybody still here? They should be equal to each other, right? So I write an equation of a line that is parallel to this. So my new equation should be y equals mx plus b. It's always going to be the equation. Y equals mx plus b, right? My slope should be the same as the slope of my other equation. So my slope should be y equals -2 times x plus b. You guys all right with that? Okay. So now they also tell me that my new line goes through -2, 5. Well, -2, 5 is just one particular set of x and y's, right? This is an x and this is a y. And over here, I have an x and a y, and I'm trying to also figure out my b, my y-intercept. So if I plug in my x and my y, then I should be able to figure out what b is. So when y is 5, my slope is -2, my x is -2, and I still don't know what b is. All right. -2 times -2 is 4, plus b equals 5. And if I solve by subtracting 4 from both sides, I get that b equals 1. Okay, so now I go back up here and almost there. I'm writing all over the place, but I know that y equals, my slope is -2x, and I know that my y-intercept is at 1. So I think that this line is parallel to this line, and it goes through 2, 5. All right, so now let's check, because we do have a graphing tool up, let's check that the equation that we just found does meet those criteria. All right, so we said my new equation is y equals negative 2x. I don't know if plus 1. Did we do plus 1? Yeah, plus 1. So this green equation is the one that we said is parallel. So do they look parallel? Yep. Does my green equation go through 2, 5 or negative 2, 5? Yep. So this would be my solution. Pretty cool, huh? It's so awesome. You can't even handle it. I actually think it's cool that you can visually see it and mathematically see it. I think that's pretty neat. It is kind of hard. It's kind of different. The more you practice it, though, honestly, the better it'll feel. Okay, so we're going to get a little bit more tricky. Just a little bit. Next example here. I think I'm going to start fresh. And here. Okay. Write an equation of a line J passing through the point 3, 2 that is perpendicular to the line K with the equation y equals negative 3x plus 1. Okay, that sounds complex, but let's kind of break it down into each part. Okay, let's say that you don't have a graphing tool up. I do have a nice graphing tool, but let's say that we don't have a graphing tool. Oh, was it this class I was going to send out graph paper to? Somewhere I have some graph paper that I can send to you. Okay, I have to do that at the end of class. I think I told you guys to remind me, right? All right, so let's say that we don't have access to a graph tool, right? We're just chunking right along here. So 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I think it's helpful to graph these because you can kind of visually see what you're trying to do. Okay, we want to write an equation for a new line. The new line is going to go through 3, 2. So that when x equals 3, 1, 2, 3, y equals 2, right here. So our new line is going to go through 3, 2. All right, that's where our new line is going to go to. Then we're going to do the old line in green. It's November, so we're busting out the Christmas colors, right? It's going to go through 3, 2, and it's perpendicular to the line with the equation y equals negative 3x plus 1. All right, so let's test out our skills here. Our green equation, let's try to graph it just using the fact that we know this is y equals mx plus b. Okay, so we know that the slope for our green line is negative 3 because it's whatever is before x. And we know that the y-intercept, our b, is at 1. So it intercepts the y-axis at 1 right here. And our slope is negative 3 or negative 3 over 1, right? So that means I rise negative 3, negative 1, negative 2, negative 3. I run positive 1. So there's a point right here. Rise negative 3, 1, 2, 3, run 1. Okay, or I'm starting again at my y-intercept, which is a 1. I rise positive 3, 1, 2, 3, run -1 over here. So then I play connect the dots. I'm not very good at this game, but I play connect the dots, and I attempt to connect the dots and create my line there. Okay. So what we want is we want a line that is perpendicular. So the last one we did, right, was a parallel line. This line is a perpendicular line. Perpendicular means that it meets at a right angle. Oops, nope, I want to stay green. Okay, so if I had to guess where my perpendicular line would be, I'm going to guess it's going to go like from here. And then I'm kind of looking sideways to see where it looks like maybe like something like that. That's what I'm looking for. I'm looking for a line that's probably going to look like this, right? But we have to figure it out algebraically. We can't just guess on a map and say, oh, that's close enough. All right. So here is the trickiest part, that the only difference between finding a parallel and a perpendicular line. Okay. When you have two lines that are parallel, nope, I need to write. When you have two lines that are parallel, they have the same slope. So it's really easy. So if we wanted to find the parallel line to this, the slope would be -3, right? When we have lines that are perpendicular, who remembers what that rule is? When we have lines that are perpendicular, this is the tricky one. They are the negative reciprocal. Negative reciprocal. Okay. So the slope of my green equation is -3. The slope of my red equation, my new equation, is going to be negative of -3, so it's going to be positive, and it's going to be the reciprocal, which is 1/3. All right, this is the trickiest part, is remembering that for perpendicular lines, the slopes are the negative reciprocals. Okay. Now I'm going to go back to doing everything the same that I did in the last problem. Okay. I'm trying to find a new line, the red line. My equation is going to be y equals mx plus b. It's always what it is. I know, because it's perpendicular, that my slope is going to be 1/3. So y equals 1/3 x plus b. Now, I have x, y, and b. How am I going to figure out what b is? Well, excuse me, they gave us a little bonus information, right? They gave us one of the x's and y's. They said one of the x's and y's is 3 and 2. So if I plug that in and I say y is 2, right? It's right here. Y is 2 equals 1/3 times x, which is 3, plus b. So what is 1/3 times 3? Just 1. So we figure out that b equals 1 again. That's not always the case. All right, so now I need to smush this all together. I'm putting my b back in here, and I get y equals 1/3 x plus 1. That's my equation of my line that is perpendicular. That's supposed to be a y. Perpendicular to my green line. So let me take my basic little graph here and see. My y-intercept is at 1 again. They share the same y-intercept. My slope is 1/3. So I rise 1, I run 3. 1, 2, 3. How How about that? That's my point right there. I rise -1, I run -3. So my line goes down this way. All right. And you can see, now my drawing is not perfect, but the green and the red line appear to be perpendicular to each other. If I did an exact graph, it would be better. But they look pretty good. Okay. And if I flip to kind of my Desmos, my graphing tool. Okay. Let me see if I can make the window small so we can keep. Okay. So the original line, right? The original line was y equals -3x plus 1. I want to change you to green. Let's see. I keep typing it. Maybe I'll get a green one. There we go. I color coordinate here. Okay. So my original equation was y equals -3x plus 1. That was my green line, right? I calculated my new equation. I said it's y equals 1/3 x plus 1. Right? And then the last thing that I said is that I have a point at 3, 2. 3, 2, not 320. Which is right here. Now if I make this a little bit bigger so we can see it a little prettier. You can see that this is your original line. This is your line that's perpendicular, and it goes through the point 3, 2. Okay? How's this feel? Good? Would you guys like to see, so there's 3 more examples. There is another one that's just like this with a perpendicular line. I can do that really quickly. And then there's a couple that are real world problems. The real world hard problems look hard. So let's go through number 3 and example 4 we'll go through those 2, and then that will be probably what we get through today. And so we will, yeah, we'll wrap up with 3, 6 probably Monday. Okay. All right, so let's just do one more. Just make sure that you're tracking along. It's all making sense. If I'm doing this and it's easy, then that's awesome. You'll have a great time with your homework. If it's still a little confusing, then never hurt anybody, right? Okay. Like I said, this is just such an important concept in terms of math. Like this idea of a line and its slope and perpendicular and parallel lines is just a really big concept in math. So I know I talked about it in Algebra 1. I know it's in geometry. I know it's in Algebra 2, and I know it's in pre-calc. So can't get away from it, and it's on your SAT, PSAT. So if you're going to work hard, make sure you work hard on this one for sure. All right. So write an equation of the line passing through the point -8, -2 that is perpendicular to the line with the equation y equals 4x minus 3. Okay. I think it's always helpful to just do a graph. Like it never hurt anybody to draw a quick graph because you can visually see what's going on. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You can see my graphs are rarely perfect. But they're enough to get you kind of started. Okay, so we know, first of all, that we have this line y equals 4x minus 3. So let's go orange for this one. All right, y equals 4x minus 3. let's talk about that equation. We know that the slope is 4, all right? Or we could say the slope is 4/1. Okay, and we know that the y-intercept, the b, is at -3. Okay, so my y-intercept is at -3, -1, -2, -3. It's right here. Make my dot a little bigger if it'll let me. Okay, my slope is 4/1. So I rise 4, 1, 2, 3, wait, 1, 2, 3, 4, run 1. Rise 4, 1, 2, 3, 4, run 1. All right, so if I connect my dots here, from here to here, I get a nice orange line that looks something like that. Okay, I know my slope, I know my y-intercept. Now I want my new line, let's see, new line is going to be purple. My new line is going to go through -8, -2. So -8 is way out here, and -2 is down here. So my new line is going to go through there, and it's going to be parallel to the orange line. So you could probably take a guess, again, what it's going to look like, right? Because you know it's going to go through purple, and it's going to be perpendicular, which means at a right angle to the orange. But we're going to do this mathematically, okay? All right, so purple is going to be my new line. I know every single time it's always going to be y equals mx plus b. Always the equation for the line, okay? I also know because it is perpendicular, it's perpendicular to the orange line. The orange line has a slope of 4/1. So that means that the slope of my purple line is going to be the negative. So it's going to be negative. Since it's positive, it'll be negative. And the reciprocal is 1/4. Okay, so I filled in what my slope is. So y equals -1/4 times x plus b. Now I have too many things. I have an x, a y, and a b. I need to figure out I need to figure out my b to be able to, the b, remember, is the y-intercept. I need to figure out my y-intercept in order to be able to graph this. All right, the other piece of information that they've given me is that there is a point at -8, -2. All right, and remember, this represents x and y. So instead of y here, I'm going to write -2, because that's what my value is, right? Equals -1/4. And then my x is going to be times -8 plus b. So -1/4 times -8, a negative times a negative is a positive, and 8 divided by 4 is 2. So -2 equals 2 plus b, or when I subtract 2 from both sides, b equals -4. So I figured out what b is. So now I go back to this guy, right? This is what I'm trying to figure out. I'm trying to fill in all my blanks. I know that my equation is y equals -1/4 x minus 4, or plus a -4. Right, I'm going to go graph it now, right? My y-intercept is at -4. -1, -2, -3, -4. It's not at the same spot. It's one below my other one, right? My slope is -1/4. So I could either rise -1 and run +4, or I can rise +1, run -4. So I'm going to do this one, okay? I'm going to rise +1, run -4. Rise, so there's a point right there. Rise -1, or rise +1, run -4. Sorry. So when I go to connect my dots to make my line from here to here, dun, 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 My graph is not perfect. Doesn't look perfectly perpendicular, but it looks pretty close, right? And it goes through my equation. So this would be my equation. Y, oops. Always want to do that. Y equals negative 1/4 x minus 4. So since we have our tool here, we might as well graph the two. So the first one was orange, right? So the first equation was y equals 4x minus 3. Oh, I got a orange. I need you to be orange. I don't know how to make the colors change, obviously. Okay. So my orange equation is the one that they gave me, right? All right. My purple equation is the new equation that I found, which I said y equals 1 divided by 4. No, negative 1 divided by 4 minus 4. And then the last thing that I have is that it goes through, the purple equation goes through negative 8, negative 2. Would even labeled it purple. So here you can see my equation. My two lines are perpendicular and look much more perpendicular on this graph. And it goes through negative 8, negative 2. Okay. All right. So we have time for one more problem. I know you guys are excited. Woohoo. It's a real world geometry problem, right? So how do we actually use slope for real? All right. Rent. The graph models, this graph models the total cost of renting an apartment. All right. Write an equation of the line. Explain the meaning of the slope and the y-intercept of the line. Okay. So here we go. We have a little chart here, right? On the x-axis, we have time in months, and on the y-axis, we have cost in dollars. So they said to write an equation of the line and explain the meaning of the slope and the y-intercept of the line. So let's just get to writing the equation of the line first, and then we'll talk about what it means. How does that sound? Okay, so what is the equation of the line always, always, always? Always y equals mx plus b. So when they want you to write an equation of a line, whenever you say that, y equals mx plus b. You got started there, right? All right. What does b represent? B represents our y-intercept. All right. Where, just looking at this graph visually, where do we hit the y-axis at? Our b is when x is 0, y is 500. All right. Does everybody agree with that? So we know y equals mx plus 500. Because that's where we intercept the graph at, right? That's our y-intercept. We got one of the things filled in. All right, we need to figure out what the slope of this graph is. Well, this will be fun, right? So let's do a little side note over here. Don't forget slope, which we did on Monday, is our change in y over our change in x. It's our rise over our run, right? We have some numbers on here. We have a number here and we have a number here, okay? So if we look at our change in y, our y is the change in the cost. So our change in y goes from $2,375, right? down to $1,250. That's our change in Y's over our change in X's. So the change in X is 5 minus 2. So even though these are huge numbers, you can still calculate the slope, right? So if I do this, I don't have the calculation in front of me. Pull up my calculator here. I should be able to do that in my head. So 2,375 minus 1,250 is 1,125 divided by 3. So that's 375. So the slope of this line is 375. That's a big slope. Slope dude is like, whoa, that's a really big slope, right? So y equals 375x plus 500. So this equation right here makes that model right there. Okay. Now you might be saying to yourself, Mrs. Ross, you just told me the slope was 375. I'm expecting the slope to go super duper like fast, right? Because the higher the slope, the higher the hill, the higher the puff positive he's got to go up. The reason is because they've changed the window that you're looking at. All right, so let me just show that really fast. If I go over to Desmos, where are you at, Desmos? Okay. So if I graph this just in my normal graphing calculator, if I plot this out, right, y equals 375x plus 500. All right, so here's my graph. This looks nothing like the graph that they have over there, right? It all has to do with the scale at which they show. So if I change the scale of this, and you don't have to know how to do this, yes, but if I change the scale and I say, well, my X is my time in months, so my months only go from 0 to 6 months, okay? But my cost of living there goes from $0 to $3,000. Now you can see, if I zoom out a little bit here, you end up with a similar graph, and it has to do, so how the slope looks on a graph depends on your scale. So the scale is what kind of makes your slope not look so high, but the slope is 375. So I just wanted to mention that if you're in your head, you're trying to, if anybody noticed that. Okay, the last two things is explain the meaning of the slope and the y-intercept. What do they mean? So here's my graph. Let me actually flip back to here. Okay, what does this mean? So what this means is that at time 0, before you move into your apartment, you're renting your apartment, you have a y-intercept of $500. So what do you think that means? At time 0, you have to pay $500. What do you think that $500 represents in terms of renting? So this is kind of stretching you a little bit. Since none of you have probably rented an apartment, I will give you a little insight in that when you go to rent an apartment, you have to generally pay some kind of a security deposit before they let you rent the apartment. And that money you get back at the end as long as you take care of your apartment over the time you're there. So $500 is probably the upfront cost to rent an apartment. Before you even pay your rent every single month, you have to pay $500 to say, yes, I'll take care of the apartment, and you get it back at the end. So this $500 would represent probably a security deposit or any upfront cost for renting the apartment. Okay, so then what does the slope mean? The slope actually says that I rise $375 for and I run 1. So that means for every 1 month, right, you're rising $375. So does it make sense that $375 would represent your cost per month? So how much you have to pay every month for your apartment? Because if you start at $500, right? And then we rise $375 and we run 1. So at month 1, you've paid $875. Then I rise $375 and I go out another month. And now after 2 months, you've paid $1,250 at 2 months. So in this particular case, the slope is representing your cost per month. And last note, because I know we're almost done. Remember when we did the slope, we did the change in y over the change in x? We kind of ignored the terms. But really, when you did your slope, your change in y is in dollars, right? This is $2,300 and $1,250 dollars per month. So your $375 is $375. Do you write that up front? Per month. So that represents basically your rent, right? So you can graph your rent with a linear equation. So then really geeky, if you stayed in your apartment for 12 months, okay, you stayed in your apartment for 12 months, then you will have paid a total of $5,000. Right? Let's say that you find an apartment and you never leave. So you stay there for 10 years. 10 years times 12 months is 1,200. So ooh, way out here. I gotta go way out here, sorry. You stay in your apartment for 12 years. No, that's not right. That's way too high. Hold on. Oh, no. Yep, that's right. No, that's not right. It's way down here. Sorry. You stay in your apartment for 12 years. Here we go. You have paid, yeah, that's much better. If you stay in your apartment for 10 years, which is 120 months, then you've paid $45,500 in rent. That's a lot of money. So anyway, yeah. All right. So I know I'm 1 minute late, but I just couldn't resist. So thank you guys for sticking with me. I hope that makes sense and you guys feel really good about slope and y-intercept and all that good stuff now. All right. Bye, Sophia. I see you waving. See you later. See you guys. Have a great day. See ya.